Ladies and gentlemen, hello and welcome back once again to the Inside Analysis Big Data Ecosystem. That's right, folks, we're taking demos from all the cool vendors in the big data space, and obviously that is a pretty hot space these days. And today we're going to look into one of my favorite things, honestly, fractals. We all know that fractals are cool. We're going to learn how they can impact your whole world of big data management, and this is good stuff. So we're going to hear from John Tobin of Tokutek, and he's going to be talking about TokuMX. So, John, with that, the floor is yours.
Great. Thanks for having us. Just a quick overview of Tokutek and what we're all about is, we're the company that invented the fractal tree index. And we found a couple of different ways to implement that and a few open source technologies, one being MindSQL and the other one being MongoDB. So our product, TokuMX, which is a drop-in replacement for MongoDB and our own distribution, is what I'll be more or less demoing for you today. Databases obviously aren't the most sexy thing, and if you know anything about MongoDB, using our database is exactly the same. You can use the exact same drivers, same application code, and use the same syntax that you're using today to control MongoDB. You can do the same thing with TokuMX. So what I'll really be showing you are kind of some of the results that you might see when you're using TokuMX in your everyday use cases. What I want to show you first is really pretty much the efficiency that you'll get using TokuMX. I think when people use MongoDB, really what they end up getting is they get a really easy-to-use, feature-rich database. And what they have to do to get better performance after a while is constantly shard. And they have to shard for a couple of reasons. One is to get concurrency because there is a database level lock in MongoDB, which is a little bit odd. And so when we implemented TokuMX, we gave it a document level lock from day one. So if you want extreme concurrency, you can get it today in TokuMX. MongoDB, ever since Mongo World in June of this year, they've announced that they're going to be doing a document level lock, and they're still getting their heads around that. We've had it for a little over a year now, and a lot of customers are coming to us from that. So, what I'll show you first is CPU usage. One thing you need to know about TokuMX is that we compress natively. So you can choose from 3 different compression libraries. One is QuickLZ, another one is zlib, that's our default. And then the most compression you'll get is with LZMA. Each one has its size on disk and CPU efficiency trade-offs. So when you're looking at TokuMX, one thing you'll notice is that your CPUs are going to be very utilized in the box. And the reason for that is really just compression and the fractal tree maintenance. What the fractal tree really allows you is extreme write performance. And the reason we can do that is because we insert messages into this thing we call the fractal tree, and we build them up in message buffers, and they cascade down. You can think of them kind of like a champagne waterfall. So when that message gets inserted at the top, we really actually acknowledge it back to the host at that point, or back to your application at that point. So you don't have to suffer the exact same disk bottlenecks that you'll get with MongoDB, which uses a B tree. That's really what the fractal tree was originally invented to solve. So what you're looking at here on this graph is the CPU usage on an AWS server that I stood up a couple days ago, and it's running a benchmark called IIBench, which is open source. You can get it off of, I believe, GitHub, Tim Callahan's GitHub page. You can run it yourself. But really what we're doing is we're inserting extremely quickly, and you're noticing here that the system's doing a lot of work, right? We're not doing a lot of I/O waiting for the disks. We're really doing processing, like I had mentioned, maintaining the fractal tree and doing compression, things of that nature. I'll scroll down here and we'll show you, this is another AWS server that I stood up running classic MongoDB, running the exact same workload on it. And what you're noticing here is high I/O weights, right? So MongoDB, in the B tree in general, and this is true of MySQL as well, is that when you're writing and you're doing transactions, the database can only function as fast as it can get the data down on disk. And the reason for that is because the leaf nodes in the B tree, which are the nodes of the tree that hold all of the information, once it gets larger than memory, they're down on disk. So every time I do an operation, I need to get that data down on disk, and I need to find it. Since it's not in memory, I have to go all the way through the memory, down to the I/O subsystem, wait for that to come back, and then do my processing. So the problem here is that your database can only function as fast as your disks. Here, we're doing plenty of functioning. We don't have to wait for the disks, and that's because of the efficient cache management and those message buffers that I talked about. Another thing in Mongo is that if you know anything about it, they use memory map files. So really what they did is they spent most of their time developing a database that was feature-rich in and of itself and didn't worry too much about the back end, meaning how it interacts with your storage. The great thing about that is they have an extremely feature-rich database, right? One that shards and replicates natively, which is fairly uncommon. And that's the reason why people like to use it, that it's open source. But one of the problems with that is that using a B tree, like I had mentioned, you get a disk bottleneck. And when you're relying on the operating system to control the cache that you use and also your I/O subsystem, you're going to get a little bit of performance overhead there, or yeah, basically performance overhead, a slight impact due to the overhead of those operations. What we do is we actually control our own cache. So you'll notice here the MongoD process relative to the vanilla Mongo or classic Mongo. So in TokuMX, we're actually controlling the cache. And by default, these are the sensible defaults we tried to put in. We'll use 50% of the cache available in the server, whereas MongoD will try to use as much as it can in classic MongoDB. So that's one of the nice things you'll get. Sometimes people like to run more than one MongoD process on their servers. And if you want to do that, you can take control of your cache easily with TokuMX with one server parameter. Now we'll actually look at the I/O utilization. So like I said, we're running the exact same benchmarks on both of these servers, and they are different AWS servers. You'll notice that the I/O utilization on average is quite a bit lower, right? We're roughly about a third of MongoDB. So Mongo is the top line, right? And it's running at 100% I/O utilization. And we're somewhere down, depending on particular times, around the 30 area. And the reason for that is since we're accumulating those writes in the fractal tree itself in cache, we're actually flushing them down every 60 seconds in what we call a checkpoint. The other nice thing about TokuMX is that it is transactional. So it has a transactional storage engine in it, just like InnoDB does in MySQL. And it's actually logging all the entries it makes. So even though we may have 60 seconds worth of dirty data in our cache, we're actually logging it, and you can recover that. If for some reason your Mongo process crashed or your server crashed, you'd be able to recover. Also in our enterprise feature, we have a hot backup plugin, which is very nice. While your database is up and running, you can take a hot backup, and that way you'll have a nice copy of your data for a rainy day, and you don't have to take any of your replica set down to do the backup. So that's a nice feature most of our customers like. And so here's the real meat of the fractal tree itself. Like I said, we're running a very insert-heavy workload. And you'll notice here that TokuMX, on average, right, is doing quite a bit more. We're doing 7,000 inserts per second on the TokuMX servers, and we're doing roughly, 900? Yeah, roughly 900 on the MongoDB servers. So, you're getting extreme concurrency, like I said, and this is just running with one single thread. So if you ran multiple threads, you'd see better performance on your TokuMX server as well. So, for big data use cases where you're trying to stream in lots of data and store it in your MongoDB database, TokuMX is a great solution for you. And we're doing all this while compressing on disk. So we're going to be quite a bit smaller on disk. And here I'm running a small query workload.
I think it's actually 90, not 900. Anyway, go ahead.
Oh yeah, you're right. It is 90. You're right. It's 0.09. You're absolutely right.
Makes you look even better.
Yeah, thank you for that. Math was never my strong suit. So we're actually running a small query workload as well on this, just to show that, you know, in a real world use case, most people are going to be doing at least some querying on their workload as well. So I don't want to make us look too good by just inserting. If we were just inserting, our numbers would be even higher. But really what you're getting with TokuMX, since we're not going down to disk as often, what that gives you is a greater ability to do queries. And the reason for that is when you go down and you do queries into your database, you're actually going to be going down to disk usually to get the data. A lot of times it's not going to be in cache when your working set is larger than RAM itself. So with all that extra utilization you haven't used yet on your disks, you can use that for queries. And not only that, we actually have some replication performance optimizations built into TokuMX. And the reason why we have those is because the fractal tree allows us things like message injection with the buffers. So what we do is we really do all the work on your primary server and your replica set. And we just tell the fractal tree on each secondary, just insert this message and don't worry about it. So you'll notice on your secondaries and your replica sets that you're doing almost no I/O. That means great read scaling possibilities on those. So if you want to do, you know, large range queries, we're going to be great. Another reason we're great is that on disk we store in large blocks, contiguously in large blocks, and those are 4 megabytes pre-compression. So that means anytime you go down to disk and you're doing a large range query on a key, you'll notice that you're going to get great performance even with the extra decompression latency that you'll be getting as we read up from disk. So if you're doing heavy insert workloads, want to do large range queries, TokuMX is definitely a good product for you to look at. Now, another thing we're showing here is the fact that we are compressing. And right here, this probably doesn't look too compelling for anyone. We're roughly about the same size on disk. But if you adjust for the fact that we're inserting so much faster than MongoDB, you'll notice that our database has many more records in it than MongoDB's does. And I can show you that right here. This is the terminal into the AWS servers. And you'll notice here on the right-hand side is MongoDB. And it's done a little over 7 million inserts into the database. On the left-hand side here, you see TokuMX. We've done almost 78 million inserts into the database. So we're quite a bit larger, about 10 times larger in the database itself. And on disk, we're still smaller. And we're using default zlib compression. So getting great insert rates with compression on disk is a win for most of our customers. Here's just some more detail on the inserts per second, but you've already seen this on the comparative graph before. And then the queries per second. And then this is just some information. Unfortunately, my server agents are having some problems, but this is some information since it's running on AWS, and some of our customers run on AWS. You can see here that we're writing a lot of bytes, right? Our database is going much faster than the Mongo database was going. So we're writing quite a bit out. So you can see that, you know, there's no fluff in these metrics. They're actually coming straight from Amazon itself. Here you can see the number of write operations we're doing down to the database itself, or down to the disk itself. So we're getting some serious throughput on the back end, and this is without provisioned IOPS on AWS, so you don't have to spend the extra money to do that. And then here we're just showing the queue length. I can drag this down, and you'll see that, right, Mongo's queue length is very big. So that's the reason why they're going to be getting horrible response times from disk, because there's a lot of queue, there's a high queue depth just waiting to go down to disk. right? We're waiting to hit inserts, and that's bottlenecking our database. Whereas with TokuMX, we have a very low queue depth, so we can service that very quickly and acknowledge back to the database and then back up to the application. That's the reason why it'll run much faster. And I think that's it for our demo.
Okay, well, I have some questions. But,
yeah.
I mean, they're not about the demo. It's quite clear from what the demo is showing that you deliver performance. I mean, there's just no question about it. I'm more interested in, the peripheral situation to this. So, yes, you're a capability that goes over the open source MongoDB. You can, the first and most obvious question is there anything specifically different that one would do if one's using MongoDB to build an application with TokuMX? I mean, is it just you don't even know it's there except the performance is good? Is that the situation?
Well, there's a couple of differences. So, like I had alluded to, we've made some replication changes. And what that means in MongoDB is it means a different oplog format. So in your replica sets, you cannot intermix classic MongoDB with TokuMX today. And it's because of that different oplog format. But what we have done is, we've made it very easy for you, or any of our customers for that matter, to migrate over to TokuMX. Really all it takes is a Mongo export, a Mongo import, and then we have a utility that we built called Mongo to Toku, which will capture the oplog changes from a classic Mongo server over to a secondary that you want to convert to TokuMX to do that incremental, those basic incremental changes in between the time you've done your export and import. So it's pretty simple. But to answer your question directly, there really is little that you need to do differently to operate TokuMX, because everything is the same at the user interface level for the most part, and it's exactly the same at the driver level. So use the same drivers you are, use the same application code, and try TokuMX. You can do it in a day, easily.
Okay, and is the DBA work similarly, there's almost no difference?
I don't know. If you like to play golf, it's a lot different, because you'll spend a lot more time out in the course.
Well, I can imagine you're going to spend a lot less time worrying about tuning the database. But is there any management difference, or is it just as if it were the same product aside from performance and tuning?
There really isn't any management difference. The reason is that, the reason why we decided to go with MongoDB and to go with MySQL is because we don't want people to have to do something painful to get better performance. Like, it's just not necessary. We do what we do really well, and that's storage and optimizing some things in code. And we've done that the best we can, and we're doing more every single day. We just released partition collections in the new version of TokuMX. Which allows people with time series data to easily drop partitions instead of doing a query and then a range-based delete in their database, which is extremely, it's complicated, and there's a lot of overhead involved in it. So we figured, right, hey, we can make an optimization.
So that's kind of interesting. And in terms of when people actually migrate, I mean, I would presume that most of your customers come to you from MongoDB, and in one way or another they're looking for better performance. When they migrate, does it tend to just be a wholesale migration? They just gradually take every application that's running on Mongo and just push it over to TokuMX?
It depends on the organization, but we're definitely seeing the edge cases. Right now we're getting a lot of enterprise adoption. Some very large use cases. And it depends on the organization, obviously, but what we do see is we're kind of viral. We get in there for one use case, somebody sees us, they see the performance gains they can get, and they start telling their coworkers, hey, this is easy, you can do this quickly, and you'll get better performance. And we're going to save money, right? It's kind of a no-brainer usually.
That's very interesting. Okay, well, I think that's all the questions I had, but I have to say I'm fascinated with what you guys are doing. It looks, I mean, if I were a MongoDB user, I would, you know, I would get a copy and start playing. I mean, I know I would, because it's like the potential performance win, you know, and a lot of these applications that people build nowadays, you don't actually know how much data is going to be there in the end. So even if you're using MongoDB in a small way, because there's some really neat advantages to that kind of NoSQL approach for document kind of data structures. You know, I would play with it and just see, because it sounds from what you're saying like there's almost no cost to doing that, and if it works for you, then go for it.
Yeah, I'd have to agree.
We like to think the cost of getting in is quite low, but the potential advantages and efficiencies you can gain are very high.
Yeah, it certainly looks that way.
Yeah, this is great stuff. Well, folks, this has been a wonderful presentation. A big thanks to our friends over there with it's Tokutek, right? And it's TokuMX is the product we've been looking at today. And I have to say, that's a lot of really good granular detail on what is happening and why it's happening. That's exactly what we like to have here in this series. So this has been another episode in the Big Data Ecosystem, folks. So thanks again, and we'll catch you next time. Bye-bye.